What is fourth dimension? Four-dimensional space is the mathematical extension of the concept of three-dimensional space. Three-dimensional space is the simplest possible abstraction of the observation that one needs only three numbers, called dimensions, to describe the sizes or locations of objects in the everyday world. Fourth dimension is where science and imagination collide. Physicists work under the assumption that there are at least 10 dimensions, but the majority of us will never see them. Because we only know life in 3D, our brains don't understand how to look for anything more. What is a dimensional space? A dimensional space, in mathematics and physics, is a way of describing the different directions or coordinates in which objects can exist or move. It's a mathematical concept used to understand and visualize the positioning and movement of things in our world. In our everyday world, we often use three dimensions made of height, width, and depth to describe the location of objects. These three dimensions create what's called 3D space. However, in more advanced mathematics and physics, dimensional spaces can have more than three dimensions, and they help scientists and mathematicians understand complex phenomena like quantum mechanics, string theory, or data analysis in higher dimensions. These higher dimensional spaces are harder to visualize because they go beyond our everyday experience, but they are essential for solving various problems and studying intricate systems. The fourth dimension. What is this other dimension? Mystics used to see it as a place where spirits lived, since they weren't bound by our earthly rules. In his theory of special relativity, Einstein referred to time as the fourth dimension, but noted that time is inseparable from space. Today, some physicists describe the fourth dimension as any space that's perpendicular to a cube. The problem being that most of us can't visualize something that is perpendicular to a cube. Researchers have used Einstein's ideas to determine whether we can travel through time. While we can move in any direction in our 3D world, we can only move forward in time. Thus, traveling to the past has been deemed near impossible, though some researchers still hold out hope for finding wormholes that connect to different sections of space-time. Beginnings of the four-dimensional concept. In the early 19th century, mathematicians and thinkers began to explore the idea of a fourth spatial dimension beyond our familiar three dimensions. August Ferdinand Mobius was among those who pondered the possibilities of this additional dimension. One of the intriguing aspects of the fourth dimension is that in it, a three-dimensional object could be rotated in such a way that it would appear as its own mirror image, a concept that challenges our intuitive understanding of space. The tesseract, also known as a hypercube, is a common visual representation of 4D space. It is an extension of the concept of a cube, a 3D object, into the fourth dimension. While it's challenging to visualize in our three-dimensional world, mathematicians use diagrams and models to help convey the idea of a tesseract. Later in the 19th century, mathematician Bernhard Riemann laid the foundations for true four-dimensional geometry, providing a mathematical framework for understanding and working with higher dimensional spaces. This work became fundamental to later developments in mathematics and physics, particularly in the study of curved spaces and the theory of relativity. Fourth dimension has many applications in our modern world. String theory, for example, relies upon at least 10 dimensions to remain viable. In mathematics, particularly in geometry, comprehending higher dimensional spaces, including the fourth dimension, is fundamental. In physics, the fourth dimension, as time in space-time, forms the cornerstone of our comprehension of physical laws and predictions. The theories of modern physics, like Einstein's general relativity, rely on this concept. In fact, time as the fourth dimension is crucial for reshaping our understanding of gravity. It describes gravity as the curvature of spacetime by massive objects, deeply intertwined with the fourth dimension. In everyday life, tasks, such as navigation and communication, heavily depend on our grasp of time as the fourth dimension. Technologies like GPS and accurate timekeeping systems rely on this foundational understanding, enhancing our daily lives. In cosmology, the fourth dimension is pivotal for unveiling the history and evolution of the universe. It assists in studying significant events like the Big Bang, cosmic expansion, and the formation of galaxies and stars, providing invaluable insights into the cosmos. Subscribe for more videos. Thanks for watching.